Let's graph this function. Now this one's going to step up the difficulty a little bit, but you got this. X squared over x squared minus x minus 2. Hopefully by now, anytime you see a quadratic, you wonder if it can be factored. And if you've already wondered that, by now you've probably noticed that it can be. Yes. Let's see, 2 and 1, -2, +1. Same thing. Okay, this form will be slightly easier to work with for the duration of our problem. I'm going to usually refer back to that. Let's look at end behavior. End behavior. This, for end behavior purposes, it's equally weighted. So x squared over x squared, as we head to infinity, x squared over x squared, that means we're going to approach 1. On both sides of the equation, right? Because infinity, negative infinity squared positive, right? So a number squared is always positive, and we're always going to approach it from the positive side. All right. What's next? This, by the way, we've already kind of implied this here, that there's a horizontal asymptote at 1. Because we have an equally weighted function, we have a horizontal asymptote at the ratio of the 2 leading term coefficients. At y equals 1. Vertical asymptotes, let's check it out. Vertical asymptotes happen when the domain is restricted on the function. That happens when the denominator is 0, because that leads to an undefined situation. Undefined, x minus 2 equals 0 or x plus 1. Two vertical asymptotes. We're going to also look at the behavior around them. Let me sketch them in first, though. Hello. Just give me one moment. Just because I'm filming something. Yeah, come on in. All right, let's see, where were we? We were looking at behavior right around the vertical asymptotes. Let's take a look at what that's going to be. So as x approaches 2 from the left side, f of x approaches. So we're looking at the first case. As we approach 2 from the left side, that means we've got a number just slightly less than 2. Let's see here. 1.99, just less than 2. Numerator, positive. 1.99 minus, oh, negative. 1.99 plus 1, positive. I think that net result would be negative. As we approach 2 from the right side, what's going to happen as we come in just bigger than 2? just bigger than 2, the y value, what's that going to be? Positive? 2.01, say? 2.01. Positive? Positive. Ooh, nice. So we're going to head on the right side of this up. At this intercept, at this asymptote here, -1, as we approach -1 from the left, -1 from the left, like -1.01, positive, negative, negative. Yeah. All right, we're going to approach positive infinity. Let's do the last one. As x approaches -1 from the right side, -1 from the right side, that's like -0.99. Numerator's positive, -0.99 minus 2, -0.99 plus 1. Ooh, also negative. Positive, negative, negative. Just right of this, we're gonna, sorry, did I say that wrong? Positive infinity. Boom, boom, we're up here. Wait, I wrote that wrong. -0.99. Let's double check my math on that. -0.99. Positive. Negative. That one's still negative. That was the one. We're going to be headed towards negative infinity. Down here. Okay. We've got our vertical asymptotes and the behavior around them. We have a horizontal asymptote. We have end behavior. Let's do x-intercepts. That's when the y value equals 0. So the x-intercept happens at x equals 0. There's only one of them. Multiplicity. 2 downwards pointing arrows in that section. That means we're going to bounce here. And I can just confirm that the multiplicity is 2 because we see that here. The numerator has multiplicity 2. So that matches up. Let's look at the y-intercept. Y-intercept is when x equals 0. All right, solve for y. Y equals 0. So the y-intercept is at that point. I mean, like, I went through a bunch of work. This is actually, I should have recognized it from that point. Look at the y-intercept now. Okay, so are there any holes? Holes come about when there is a common factor between the numerator and denominator. For instance, if I had x plus 1 over something, 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 x plus 1, the x plus 1 would be a common factor. And at that point, when x is -1, that would be a hole. I don't have any common factors. No common. With all of this, my goal was to sketch the graph. Let's do it. Sketch the graph here to here. here through there to here. Here to here. Sketch the graph of that function is done.